Preventing the foam shrinkage we talked about before. In this video, we will go deeper to uncover why shrinkage happens and how to pinpoint its root cause in your own production. To understand shrinkage, you first need to know two key reactions important in the forming: the forming reaction and the Joule reaction. In the forming reaction, isocyanate reacts with water, forming urea bonds, where the carbon dioxide and kid that gives expansion the foam. In the Joule reaction, isocyanate reacts with polyols to form uracil bonds, building the polymer skeleton that supports the foam structure. Shrinkage happens when these two reactions lose balance. If the Joule reaction is too slow, the foam structure can't cold, is collapsing and shrinkage. But even when the Joule reaction is too fast, shrinkage can still occur. That's because the foam may close too early, trapping gas inside. When cooling down, the trapped gas contracts and the foaming volume decreases. So, both slow and faster generation can lead to shrinkage, but for different reasons. Let's take a quick look at a comparison chart showing these two shrinkage types side by side. Now you know foam shrinkage comes from an imbalance between the foaming and Joule reactions. So, what caused this imbalance in real production? In the next episode, we will explain the key reasons and show you practical ways to fix them. Don't forget to like, subscribe, and follow us for more insight on flexible pure foam production. If you are looking for foam machines or technical support, check our official site. The link is in the comments. See you next time.